Hello viewers, welcome to Gateway Learning Center YouTube channel. I'm your tutor Nathan. Today we're going to look at chemistry under organic chemistry. Now under organic chemistry, we'll focus on esters. So looking at esters, So under esters, we know that the reactants of esters, talking about the reactants, these are things which will react, or substances will react in order to form a product or product. So the reactants of esters, number one, we have alcohol. Alcohols, then number two, we have carboxylic or carboxylic acids. So these are two reactants which will react in order to produce an ester. So when alcohols react with carboxylic acid, we produce an ester. That process is called esterification. So esterification is a process where alcohol and carboxylic acid react to produce this ester as a product. So each time this process takes place, water is lost. So I say each time an ester is formed, water is produced as well. So whenever we form this ester, we're expecting also water to be produced. Now, let's talk about alcohols. So examples of alcohols. We have methanol, we have ethanol. Remember, under alcohols, alcohol is also one of the homologous series under organic chemistry. So alcohol is also like a subtopic which has the uses, the formation of alcohol, then in their structures, isomers, and their chemical and physical properties. So we taught about alcohols. If you want to know more about alcohols, you can go back on our previous videos. Then you can search for organic chemistry under alcohols. So we have ethanol, we have methanol. Remember that ethanol is the very important alcohol and alcohol part. Then we have also propanol. So we have propanol, ethanol, methanol, you have butanol, you have pentanol, you have hexanol, heptanol, octanol, nonal, and decanol. That is 10 now. So these are examples of alcohol. So before I talk about the carboxylic acids, let us know how to write the molecular formula and their structural formula, which will help us to move on carboxylic acids. Once we understand carboxylic acid, their structures, their molecular formulas, then it will be very easy for us to understand esters. So this is not the complicated part. Just a simple thing which we're going to look at. So let me talk about alcohol just for a brief one. So methanol, we know that the general formula for alcohols, we have CN, H2N plus 1 then hydroxyl group. So the functional group of alcohols is OH, hydroxyl group. So since methanol is on number 1 is N, we put 1. So it will be C, we don't write 1 of course, then H, 2, then 1 here, then plus 1 OH. So the final molecular formula for methanol will be CH, then 2 by 1 are going to get 1 plus 1 are going to get 3. So 3 here, then OH. So this is how we make the molecular formula and alcohols. So having known this, we can also draw the structural formula for the same methanol. So in terms of the structural formula, we have 1 carbon. So we're going to write this carbon. We have 3 atoms of hydrogen. So here, here, and here. So something like this. Then a bond will attach to a carbon to give us our hydroxyl. So this is the structural formula, then this is the molecular formula. So the way I've made methanol, this is the way we make all the molecular formula of alcohols. So away from this now, having that knowledge in our mind, we can talk about the carboxylic acids. So carboxylic acids, all the carboxylic or carboxylic acids, we need to know that all these are weak acids. Reason, a weak acid dissociates or ionizes partially whenever it dissolves in water. So this is the reason why they are called weak acids. So the general formula for this, it's not that much different from alcohol. So it will be CnH2n plus 1. Then its functional group is written like this. So CO, then H. Or someone can say CO2, then H. So this and this are same. So since we have this general formula, examples of these acids. Examples, number 1, we have the same principle which we use to mention or to name the hydrocarbons. The prefix name will be the same. So meth, it will be methanoic. Number 2 will be ethanoic. And number 3 will be propanoic. Okay, so these are alcohols, then these are acids. Now, these acids, they are ending with OIC, then alcohols are ending with OL. So alcohols end in OL, alkenes end with ENE, then alkanes end with ANE. Then carboxylic acids end in OIC. Now, there is a different scenario to make the structural formula and the molecular formula under carboxylic acids. So what is that scenario? We are saying, let me use this space. Methanoic acid, using this general formula, where there is N, are going to put 1, so it will be C, we don't write 1, then H, then from here, 2, then open bracket 1, then plus 1, then this functional group. So if you simplify, I'm trying to be slow so that at least you see how I'm coming up with the formula. So then 2 by 1, it will be 2 plus 1, it will be 3. Then like that. Now, if you end A to mean the molecular formula for methanol, for methanoic acid, your answer is wrong. So why are we saying our answer will be wrong? For the methanoic acid, since it is on number 1, it needs to have 1 carbon, but here you have 2 carbons, here and here. So what what do we do now? Whenever you are making the molecular formula for acids, carboxylic acids, you need to understand one thing, which we say here we need to remove 2 hydrogen and 1 carbon. We subtract 2 hydrogen and 1 carbon. What will remain will be the final answer as our molecular formula. So if you remove 1 carbon, it means this carbon is gone. If you remove 2 hydrogen, remain with 1. So it will be hydrogen, then this functional group. So this is the molecular formula for methanoic acid. So it's different from alkanes, alkenes, and alcohols. Those 3 I've mentioned, we don't remove anything. We just put in the numbers, depending the number of the carbon we want, then what you are going to form will be our answer. But on the carboxylic acid, it is something different. Remember always, remove 2 hydrogen and 1 carbon for it to remain with the final answer. If we can look at another example, this was methanoic acid, the first one. Let's try to make for the second one, ethanoic acid. So for ethanoic acid, we know that ethanoic is on number 2. So what is N? Remember the formula here, CnH2n plus 1, then the functional group there. So where there is N, we'll put 2 because we are on number 2. So I'm going to put 2 here, then 2 open bracket 2 plus 1, then cool like this. What next? So what next now? Remember, we remove 1 carbon and 2 hydrogen. So if you take 1 carbon here, remains 1. Then take 2 times 2, it will be 4. 4 plus 1, 5. 5 minus 2 to give us 3, like this. So this is the molecular formula for ethanoic. If it was propanoic acid, we put 3 here, so 3 by 2 to give us 6. 6 plus 1, 7, then here to be 3. So you move 1, remain with 2. You remove out of 7, remove 2, remain with 5, then the cool group. That is how we make the molecular formula for carboxylic acid. Don't confuse carboxylic acid with alcohols. These are 2 different things. Remember, we are dealing with esters, but we need to have the background of acids and alcohols. Alright, so we move from there. The next thing we're going to talk about, we will talk about how to form the structural formula for the acids. So, having known how to do this, hope you can do this. You can try from propanoic up to decanoic, the 10th one. So, let's say now, the structural formula for this one will be C with 3 hydrogen, then this part. Now, when we are writing the molecular formula and the structural formula, the functional group will be written in a different way. So this functional group here, in the molecular formula, it's like that. But in the structural formula, the functional group will differ. So I'm going to write our functional group in this manner. Okay, so this part, it will be written like this. We have this C, this is my carbon, I have 2 atoms of oxygen. So I'll write the double bond on top, then I'll put oxygen. Then down here, I'm going to write a single bond and add hydroxy. So 1 oxygen has been removed. I've remained with 2 elements, which is oxygen and hydrogen. So I'll write now O, then hydrogen. So this is how we write this part in this manner. functional group, which is here in the molecular formula. Remember that don't put this bond to hydrogen, then write oxygen. This will be wrong. So always a bond should be attached to oxygen, then hydrogen, like that. So this part is representing or is telling us to say this is the functional group of carboxylic acids. So this is how we write the structural formula and the molecular formula. Maybe someone may ask, what about the first one? So the first one to just be like this hydrogen, then a bond will come to carbon, then we do double bond, then a single bond and hydrogen. So this is the structural formula for the first member under carboxylic acid, which is methanoic acid. So this is a brief background of carboxylic acids and alcohols. Now let's now go dive into our main discussion for today to make esters. Okay, so whenever we are making esters, there are also simple rules which we are going to consider and understand. Then our topic of our discussion will be very simple and plain. So when we are making esters, remember I talked about whenever an ester is produced, water is also produced under the process called esterification. So rules from alcohol part. So let me say alcohol part. What are some of the rules should we understand under alcohol part? Number one, if I have methanol like this, I have methanol. Now, for me to form an ester, this methanol, which is alcohol, will lose its anode part. So alcohol will lose its anode part, and then that anode part will be replaced by YL. What am I saying? We are saying that from the alcohol part, we are going to remove this part. So anode part is removed and replaced with YL. So this anode part is removed and replaced with YL. So if we remove this part now, it will be meth. Then I've removed this part. So what will happen now is that since I've removed this part, the next thing which will happen, I'm going to replace now it with YL. So I'm going to form something like this, methyl. So this methyl is the first part of an ester. This is what we do from the alcohol part. Any alcohol you can try to make, you need to do the same thing. For example, let's get butanol, which is the fourth member. So I'm going to remove the anode part. So this anode part will be removed. So if this part is removed, I'll remain with this. Then I'm going to replace this part with YL. So it will be something like this. I'll form butyl. So this is how we make the alcohol part. If this is clear, let's talk about acid part. So 1, 2. So the rules on alcohol, they are done. The next part, we'll talk about the rules under acid. So whenever we're dealing with acids, we are saying that, let's get an example of an acid. Ethanoic acid. Okay, ethanoic. So this ethanoic, under acid part, what are we supposed to remove from there? Okay, so I'm going to remove IC, this IC, we are saying IC is removed and replaced with ATE. IC is removed and replaced with ATE. So I'm very slow, such that you understand for better. Then from there, we'll say, since we have removed IC, we are going to remain with something like this, ethanol. Then I replace ATE, it will be like this, ethanol. So ethanol part has come from acid by removing IC and replace it with AT. So I've made two things. This part, we have made it from the acid part. Then I've also made this part from alcohol part. So whenever these two things have been done like that, an ester has been formed. That is how we form esters. Now for us to mention an ester, we'll say now, okay, maybe before I talk about how to write an ester, let me get another example on the acid part so that we can solidify our understanding. The next thing, let's get, for example, the number 61, which will be number 2, which will be hexanoic. So let me use this part. So this hexanoic, we are going to remove IC and replace it with ATE. So if you remove this part, it will remain like this, hexanol. Then we replace ATE like this. Then it will remain hexanol. So we have made this by removing IC and replace it with AT. Under alcohols, we say from the alcohol we remove the anol part and replace it with YL. Okay, so having done this part, we can now say the part of making an ester is done. If I want to make, if I react methanol and methanoic acid, so methanol and methanoic acid, okay, Hope you have seen. I want to clear the space now. Hope you have seen what I've done. So you can pause the video if you want to copy. You make your own notes, you copy, then you compare the notes. But this is simplest way of explaining how to make Esters. You never go wrong once you understand this part. Okay, so now let me create space here. Okay, now formation. Formation of Esters. Formation of Esters. So let's say methanol plus the first two alcohol are liquids, but ethanoic, when the temperature drops slightly below, it turns into a solid. So methanol is a liquid. Plus, we can get any acid of our choice. Let's get ethanoic acid to produce. What are we producing? What could be the product? So the product here will be methyl ethanol plus water. Let's talk. Okay, so methanol plus ethanoic, we are forming methyl ethanol plus water. Remember, there are two conditions which are needed for this process to be successful. So here we need concentration sulfuric acid and a bit of it. So from here now, we can write this equation into the chemical equation. So methanol is on number 1, so it is C, which is first one, then 2 times 1 plus 1 to give us 3, then OH plus ethanoic acid, so number 2, so CH3, I guess. Then you have this part, you have concentration of H2SO4, then you have it like that. So what are we forming? We are forming CH3, then OO. Now, I must mention here to say, you start with an acid, then this hydrogen from an acid will be removed or will be replaced. So this hydrogen here and this hydroxyl here will be replaced. So hydroxyl and this hydrogen, these two are the ones that will form water. Therefore, if we remove hydrogen here, then this part will sit that side. So it will be CH3, then yes, then plus H2O. So this hydrogen and this hydrogen, we have 2 hydrogen and this oxygen which is here. So remember, each time an ester is formed, water is also produced. So this part now is our ester, which we are looking at. So methanol and ethanol, we have formed methylethanol. So this is how we write methylethanol plus water. So in that way, an ester has been produced, which is very simple. Now let me also just demonstrate how to write esters, not using normally the entire equation, but just using two elements. Then those two elements will help us to understand how to form ester. Because if you know how to make esters, it means even the structural formula will be very easy. So that is an equation. So you can copy, you can pause the video, you copy, then at your own time, you go through. Alright, so if you have two reactants, if I have ethanol, and the butanoic acid, go ahead and predict what is the name of an ester which will be formed when ethanol reacts with butanoic acid. What could be the product? Okay, maybe that is correct. Now, ethanol, it will be ethyl. Then butanoic will be but. So butanate. So ethyl butanate. Ethyl butanate is an ester. We have talked about where this part is coming from and where this part is coming from. So always start with an alcohol, change an alcohol into ethyl, then from there you change an acid into a knot, then you combine the two. That is how we produce. Hope you have enjoyed the video and you have understood. Now the last part, let me talk about maybe just two structural formula, how they are being arranged. When you know that, the entire part of the discussion has been done. Alright, so in terms of structures, let me get a structure of ethanol. Since ethanol is like this, that is the molecular formula for ethanol. So structural, it will be these two carbons, then one hydrogen, and of course this. Okay, so this is my ethanol. Then plus, let me get let me get propanoic. So propanoic is on number 3. So we'll say one carbon, another carbon. So 3 times 2, it will be 6, plus 1, it will be 7, minus 2, it will be 5. Then here, alright, okay, let me do the reverse thing so that I simplify the work. Okay, so this one, alright, it's put your mind to say that's an alcohol, an acid, then this is an alcohol. So I'm trying to react these two products, reactants. For us to form water, then what will remain will become an ester. So in the first part, this alcohol will lose its hydroxyl. It's a point I want to emphasize. We have hydroxyl, we also have hydroxyl. So since we have hydroxyl, we also have hydroxyl. We just need to make water, not hydronium, where we're going to have 3 atoms of nitrogen. So this acid will lose its hydroxyl entirely. Then this alcohol will only lose hydrogen. So this part will give us H2O. An acid has lost its hydroxyl, while an alcohol has only lost its hydrogen. Therefore, what has remained here? What has remained here? We have something like this. So I'm going bit by bit, very slow for you to understand, because this part is a challenge to others, but we want to make sure that that problem is no longer there. Then here we have remained with this part, then a bond of course is there. Okay, so this is what has remained. Now for you to make an ester in terms of the diagram, just need this one to shift a bit on top such that this bond can come and match here. So always, whenever, in most cases, whenever you're writing the structure now, the product, the acid part is higher a bit than the alcohol part. So I'm just going to lift this part and put it somewhere here so that I can form my ester. So let me use this part. So I do have this. So I have two carbon there. Then first let me lower it down to give chance to that one. So let me write somewhere here. Hope the camera is on point. Okay. Then have this oxygen. Then this react with now will be removed because we have already made the product. So it will be something like this. Okay. So this is now our answer. In terms of a structure, this is how we draw structure part and Esters. So if you have any questions, you can now comment in the section below. Your comment, you can specify where I've not understood, so that at our time, when we check your comments, we go through, then we redo those parts which you have not understood. You can also give us a direct call at this number or WhatsApp. So at 0966993848. So you can contact us on that number, then we see how we can help each other. For today, under Esters, I think we are done. The next time, we'll also post a new video which will deal with polymerization. Then from there, we'll also revise the all concepts under alcohol and the all concepts under carboxylic acids. Then for alkenes and alkanes, we'll combine them also on that part. So thank you for watching. Remember to subscribe to our YouTube channel and share the link to your friends so that they can also take part and benefit from the same content you're benefiting. Remember, we offer mathematics, science, which contains the chemistry part, then also physics, then bios, English, RA, civic, and commerce. So for now, thank you very much.